friction circle method for analyzing finite slopes. For analyzing finite slopes, it is a graphical method. It's a graphical method. So what we are going to do in this method, so here you see, I just clearly written everything, each and every step. First draw the slope. First you draw the slope. Now how to draw the slope with an angle beta. After drawing the slope, draw a slip surface and measure the area. So draw a slip surface. Take one arc with a radius r. And try to measure its area. So the advantage, if you measure area, you will get weight because weight is equal to gamma into volume. I told you this is a two-dimensional problem. So you can see area, but you cannot see the length, running meter length. So 1. So now you can see I got W. So you know that weight is always passing at the center of gravity. So I can able to show you W. W means weight of the sliding wedge. Weight of the sliding wedge. Now you see what we have to do. Draw a circle. Here you see from your center of rotation, draw a small circle. What is the radius of the circle? Can you tell me? R sine phi m. So you may ask, what is r sine phi m? R sine phi m is the radius of the friction circle. So someone can ask me, sir, what is phi m? You know, phi m is mobilized angle of internal. Last class we discussed about what is phi m, what is cm, mobilized angle of internal friction. Now let me tell you. So draw a circle now. What is the radius of the circle? The radius of the phi circle is r sine phi m. Now you see what we have to do. Next line. Third point I am telling you. So first point, draw the slope, given slope. The second point is draw one slip surface and try to get the weight of the sliding wedge. Now the third point, draw a friction circle with a radius. You see each and every step is written r sine phi m. Now the fourth point, let me tell you, the fourth point, a line is drawn parallel to chord. You know what is chord? This is chord here. So you can ask me what is chord. Chord, it is the longest one. See, this is the longest one. Longest line that is joining the two extremities of the arc, two ends of the arc. This is called long chord. You know the meaning of long chord. Now you see, draw a line parallel to the chord. See, here you see. Now I am drawing a line parallel to the chord. Here you see. So now this, see, the distance I can tell you. This is the distance from center of rotation to this point is small a. Here small a is equal to r into LA by LC. Someone can ask me, sir, what is LA? What is LC? I can tell you. LA means length of the arc. Pi r theta by 180. LC, length of the long chord. This is LC. Now I have drawn one line which is parallel to, draw a line parallel to chord at a distance of A. I can tell you what is small a from O to this line. So while you are drawing this line, it must be parallel to your chord. Okay, so now you can see a triangle. Here you see, I have weight of sliding wedge. I have this P. Just now I got this point, the point of intersection of this weight and the line. You see, now you can see the reaction R is also passes through point P, which is tangential to friction circle. Now you see, draw a tangent to friction circle. Just follow my Like, just follow my hand. You can see here. So this is reaction. R. It is. I have drawn one tangential. This is also passing to point P. Now you can see here. You see, I have weight W. It is absolutely vertical. So I have reaction R. So this reaction is from the tangent of this R sin phi. Okay. And one more point I would like to tell you. So here you see, I have reaction R. I have W. Now you see, this is PC. PC. Now you see how to calculate total cohesive force. So here you see this is total cohesive force, which is equal to Cm into length of cord. M into length of cord. Cm into length of cord. So now you can see now Cm is equal to capital C by length of cord. Now you can see what is Cm? What is Cm? Mobilized cohesion. Mobilized cohesion. Now factor of safety with respect to cohesion is equal to, what is the factor of safety with respect to cohesion? Can anyone tell me? Hello? What is the factor of safety with respect to cohesion? What is the formula to calculate factor of safety with respect to cohesion? FC is equal to C by Cm. Given slope. Here you see I have a slope. I have a slope. So first you draw this slope. So after drawing this slope, select one slip surface, what I call the failure surface. So the thing is, first we need to calculate weight of this sliding surface. Here you can see definitely the weight is vertical, which is acting at the center. So I got W. How I got W? W is equal to gamma into area into 1. Gamma into area into 1. So after getting weight, so now what we have to do now is, so draw a line. Here you see draw a line parallel to chord. So parallel to chord. So this line, see, parallel to chord at a distance of small a. I can show you here. Small a is equal to capital R into LA by LC. Now you can ask me, sir, what is capital R? R is radius of the circle. What is LA? LA is length of the arc. LC, length of the chord. Now, the total cohesive force, capital C, which is passed to the point P, which is at the intersection of vertical line through W. That means, vertical line through W. Now, which is intersecting this point. You see this vertical line having intersection. So you can see now this is point P. This is the point of intersection between the W line and the C line. Now someone can ask me what is C? C means total cohesive force, which is resisting force actually. That's why we are drawing it is in upward direction. So why you are writing upward direction? Because it is resisting force. Now let us discuss now. Capital C is equal to Cm into LC. Cm into LC. Now, but I want Cm. So Cm is equal to C by LC. C by LC. So now how to calculate factor of safety now? Factor of safety with respect to cohesion is equal to C by Cm. C by, this is Cm. What is Cm now? Can anyone tell me? Cm means mobilized cohesion. So this time I am trying to explain you how to determine mobilized cohesion. Mobilized cohesion. So this time, so how to determine Cm is equal to C by LC. Cm is equal to C by LC. What is LC? LC means length of the, here you see dotted line in this figure. LC means length of the chord. Length of the chord. So here you see, this is the force triangle. Here you see, we can see three forces here. So this is cohesive force. This I would like to write Cm into LC. I have weight, vertical force, W, no doubt. and we have resultant here. Now you can see the resultant. Let me tell you, this resultant is, if you draw a line, so see it has to touch the circle at one point. So if you draw a tangent, in other words, if you draw a tangent to this friction circle, you know the radius of the friction circle is r sine phi m. If you draw a tangent, it touches the same point P and it gives the resultant. Gives the resultant. So it gives the resultant. If you started drawing a tangent to this friction circle, r sine phi m, the radius of the friction circle is r sine phi m. So you know that the friction circle having radius r sine phi m. So draw a tangent to, now this which touches the this. If you started drawing a tangent, it touches the your same point P. So now we are getting the reaction. So if you see here, you are getting the reaction. Now three forces are there. One is weight. Second one is cohesion. So as you know, this is cohesive force. And the third one, which is very important, but don't forget this point of intersection P. So now the R is resultant. R is resultant. So what we calculated at the end is what we calculated at the end is CM. So once you know the CM, you can able to calculate factor of safety with respect to cohesion. So what is factor of safety with respect to cohesion? Can anyone tell me? C by CM. C